Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Welcome to Astronomy Live. Tonight, we're going after Atlas one more time. See what we'll see. Reports are that Atlas has fragmented into at least two major fragments, with smaller fragments visible up the tail. So, I don't know that we'll be able to resolve them. The latest image I saw came from the Virtual Telescope project. They take some fantastic pictures. But their telescope is twice as large as mine, so I may not be able to separate the fragments. But still, we're going to take a look at what we can see with Comet Atlas. So I'm just finishing right now, focusing the telescope, and then we'll proceed on to the comet. Looks pretty good there for focus. It's just a short skip over to the comet. Now let's see if we have a suitable autoguide star as planned. Oh, nope, I'm taking pictures of the wrong thing. Let's use the autoguide show. Okay, so we have a star there. It's not really bright. Move that star to where I want it to be in the autoguider. I also don't know how long I'll have on the comet tonight. I actually may want to change where I had planned. Yeah, I'm going to change where I planned to put that autoguide star. I was going to center it up, but actually I'm going to put it in the top right corner, because I want to get the comet closer to the center of the field of view to maximize the view at the start of the stream. I don't know what the weather is going to do later tonight. I'm going to try to stream for as long as I possibly can, as long as the weather allows me to. But in case the first images of the evening are the best images we get, which is likely, the comet's also descending towards the horizon, I want to position the comet to be in the optimal place as much as possible for the start of the webcast. All music tonight is brought to you thanks to Stellar Drone. And you can find the information about the telescope being used in the video description as well. I'll just do a quick overview. This is an 8-inch Meade LX200 Schmidt-Cassegrain Classic. The camera is an SBIG ST2000 XCM single-shot color deep space camera from SBIG, and I'm also using an A07 adaptive optics unit. Like it's on a dead pixel, and move it just slightly to the right, and then looks good. Okay, so we will start autoguiding here. If I can get away with half a second autoguide exposures. I'm guessing probably not. No, that's not really an idea. Let's crank that up. 7 seconds. The autoguide star tonight is not as bright as I like to have it. Even that is not super ideal. Okay, we'll go to 0.8 seconds. Alright, the adaptive optics just won't be as effective as it normally is, but it should be okay. Okay, we're going to start saving these pictures, and we're not going to use subframe. We're going to run 2-minute exposures, and go. Alright, taking our first picture of Comet Atlas now. Using any light filters? No. In fact, with the adaptive optics unit attached to the SBIG camera, you have to remove the threaded slot for the filters. So, with a single-shot color camera, normally you wouldn't have a filter wheel in front of it because it's already got color filters built into each of the pixels. Just like a consumer digital camera. But it does come with a threaded slot for additional filters. You have to remove that to attach the adaptive optics unit, so there's not even a waveforming to attach a filter. Is it getting too loud? Sorry. I will turn that down. Better? Hopefully. Scotty, she's breaking up. Yes, unfortunately so. Unfortunately so. I don't know how much we're going to see of the comet. Last I saw it was almost a week ago at this point, and it was quite dim. If you've seen my latest time-lapse, you can see the progression of that, with the comet having already definitely peaked in brightness, as far as we can tell, and it's been progressively getting dimmer and harder to see with this telescope. So we'll see. I've got the focal reducer on there tonight to maximize the light gathering ability, and we'll see what happens. I should probably turn off my front porch lights at this point. I was actually leaving them on a little longer than usual intentionally to distract some of the bugs that were looking for a nice bright light source, and they came and swarmed my laptop, so I turned on the porch light and gave them something else to buzz around. I'm going to turn down my laptop brightness now that everything is set up, and then I can turn off my porch lights. Okay, well, we've got a nice image there. It's going to take a dark frame to get rid of those colorful pixels. Those are hot pixels. The comet is faintly visible in the middle. Looks like it's right next to a star. Oh, I heard something come buzz around here. Man, these bugs tonight are really interested in colorful lights. comet is very, 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 very faint. Is that enough varies for you? It's right there where the mouse cursor is pointing. That's interesting. I don't see... Okay, I see. Wow. Is that really the case? Ha ha ha. Trying to see what this star right here is. There is a star consistent with that position. The comet was... I was expecting it to be a little further back. Yeah, the moths are definitely taking it. The beetles and the moths are taking a serious interest in my laptop, so apologies if you hear buzzing. I'm trying to keep them away from the microphone, but they're not cooperating. I need a lamp that I just stick somewhere up the driveway to keep them distracted. Okay, so there is that. So dark frame is now subtracted. You can see better what's going on. According to Sky Safari Pro, I mean, that is kind of interesting. I think Sky Safari Pro is... No, I guess that is... It's hard to say. It's hard to say exactly, but I think Sky Safari Pro is expecting the comet to be more back here. But I haven't updated the orbit on it in a while. Oh, we lost the guide star brightness. Oh dear, okay. Stop. Take an image. Okay, so it lost the guide star. Or it could be clouds. What's going on? I can't see. Well, I guess I can see some... Yeah, I can see some haze. It's general haze is the issue. Okay, well, let's crank it up. Give it a full second exposure. The guide star is still right where I left. Jeez. Freaking sorry. Beetles and stuff flying right into my chest. I think the guide star is still there. It's just hard to see because of all the haze and general cloudiness in that direction, unfortunately. Okay, now I don't even see it. So we are in cloud situation. We'll just have to wait it out. Sorry, gang. I was just a little afraid of that. It was a bit of a long shot tonight, but we have a picture, at least. So that's cool. But I'm going to have to wait the clouds out. Let me take a look at GOES. See what the weather satellite shows. It's not really thick stuff, per se. And I am a little, maybe a little concerned that it actually drove me off the guide star. It's possible that could happen. Because... No, there's haze. I can tell Venus is much dimmer than it should be. It's haze. Yeah, there's definitely haze in that northwest direction. So let me take a look at the weather satellite. Get an idea of what we're dealing with. multispectral IR doesn't really show anything at my location. Tampa's definitely getting hit, but I should be okay here. But it's definitely true that it's thicker up to the north. I think if we give it a few minutes, it will clear. Oh, there's the guide star. Okay, it did not drive me off the guide star. Good, we're back in business. So, in the interest of protecting the image from going bonkers, I'm tempted to, run full second exposures on the guide star, even with a much slower guiding rate. That way, we don't get driven in some weird direction, because what can happen is if it dims a little too much and we lose the signal to noise ratio on it, it will just ruin the picture that's being taken and potentially drive the scope in a direction that when the clouds go away, the guide star is not in view anymore, because that guide star is up in the corner there, so there's not much room for error. The scope will start chasing its own tail if you allow it to continue thinking it's auto-guiding on a star when it's actually just noise. It's just randomly driving the scope in random directions, trying to keep what it thinks is the guide star center. It's just tracking random camera noise instead at that point. So, if you run slightly longer exposures, you can tolerate a little bit of haze, as long as it doesn't completely obscure the star. But if you're running fast exposures and your signal to noise ratio is already low, then you have less room for error in terms of the brightness of the star. If it's dimmed at all by haze coming over, even if it's thin haze, it could cause you to lose the lock on the star, and then the scope's driving in random directions, which is no fun. Not very quickly, mind you, it's a pretty slow drive, but it's enough to, maybe mess things up with trying to reacquire the guide star later on. It just is time consuming, not to mention ruining any images that are being taken for sure. It's funny though, because the first image looks so good. Oh, and we have a super chat here from I'm gonna say that's like a French name, perhaps. I'm gonna butcher the pronunciation there, but Pinochet, maybe? Coffee funds from Dear Leader. Thank you. It's $6.99 Canadian. So the fragments of this comet will not be endangering Earth. We don't have to worry about that. The comet will continue along the same general orbit as the original. The fragments will continue along the same general orbit. Oh man. The autoguider is already almost clouded out again. See, I'm looking at this max value here. This is the maximum brightness pixel in the autoguider image, which you can see is almost just pure noise at this point. The star's just barely there. But it will keep trying to track, even if it becomes nothing but noise. I'd like to see that max value no lower than 300, and preferably 400 and above. When it drops below 300, it's like hit the brakes time. And I can tell this image, in general, is not as good in terms of the transparency of the atmosphere. There's more haze. So we will wait. In the meantime, we can monitor with auto-guide images. Okay, so the auto-guide star looks like it's back. It's going to be one of those nights, isn't it, where I'm just fighting it the whole way. Sort of stop, reassess, stop, reassess. Okay. So, see here, the max is it's around 350, close to 400 sometimes. It's not great, though. Yeah. Alright, I'm going to try it. We're going to try 2-minute exposure again. See if we can get it in before the situation worsens. And so, in terms of tracking orbits and such, I will be trying to do another video here on the Comet soon. I still want to do the what would it take for this comet to hit Earth type video, showing that based on my own tracking data here. Show how much the orbit has been perturbed by the fragmentation event. Fortunately, we've got some good data from before it fragmented, and now we're going to have several nights. I mean, we already have a few nights worth, but we'll have even more data now post-fragmentation to compare it against. So that'll be interesting. I also have the astrometry done now on Asteroid 1998 OR2, which will be making a close approach to Earth late this month as well. My data shows a close approach distance of about 16 lunar diameters, or 16 times the distance to the Moon, similar to the official orbit. And right now, my desktop is running an integration in Linux on a series of Monte Carlo solutions of that orbit. So basically, by adding a little bit of Gaussian noise to the input data, you can generate orbit solutions that would roughly fit the observations that you made. You keep that noise that you add to the input very low, you know, but just add a little bit of random noise to each of the observations when calculating the orbit, and then you have as an output virtual asteroids that represent possible solutions, possible orbital solutions. And that gives you an idea of how uncertain your orbital solution is, how much uncertainty there is in the data. You can plot that out and see if you have a very tight solution, if all of those virtual asteroids agree with each other in terms of where the asteroid should be, or are they spreading out along the orbit, which indicates that you don't have a very good idea of where the asteroid should be. So that is running on the desktop right now. Basically, it's running all of those solutions. There's over 600 solutions for the asteroid's orbit that are running right now in a solar system integrator, an in-body simulation that is factoring in the gravity of the planets on each of those 600 solutions to see where they end up. And I can tell you right now, none of them end up hitting Earth or coming significantly closer than the nominal orbit solution. It shows a very, very tight cluster. In fact, it almost looks like a single point when looking at a view of the solar system as this asteroid approaches Earth. So that tells me my solution is very, very good, very, very consistent, and shows that it will miss Earth by about 16 times the distance to the Moon. So I'll be doing a whole video on that. I had to basically create a new program for running the in-body simulation. I used to use ORSA in Linux, but I can't seem to get that program to compile anymore. I can't get it to install on any modern distribution that I use. I usually use Linux Mint, and for whatever reason I can't get it to compile. It did have certain dependencies that it required. I think it even needed like a Fortran compiler of a particular type. I don't know. I installed all the dependencies it was asking for, and it still doesn't work. So I just finally said, you know what, I'm not going to waste any more time with this. I'm going to see if there's another solution I can find out there. And sure enough, I found a package for Python called Rebound, which allows me to run in-body simulations in Python. So very handy package there for Python, and I'll be explaining all that in a later video. But the bottom line is it's a much faster way for me to just generate a series of plots of the solar system showing all of these asteroid solutions with gravity of Earth and the other planets being factored in. So you can actually see, if you look closely in the simulation, you can see how the orbit of the asteroid changes in response to Earth's gravity as it makes this close approach. So that's kind of cool. Yeah, Swan is about as bright as Atlas was. but it's expected to fizzle out too. It's green too, really pretty. Yeah, I saw that comet there from Project Alice. Unfortunately, Swan is very low on the horizon at morning twilight from my location. Less than 10 degrees, really. So, not visible from here, basically. I've got way too many trees in the east. I'd have to go out to a boat ramp or somewhere that I have a clear line of sight to the horizon. And with the current situation right now, that's not such a good idea. So, I'm not currently planning to try to observe Swan. It's just not ideally placed for observing here from Florida. Its declination is very low. This comet's declination is very high, so it's kind of the opposite situation. With this comet, Comet Atlas, the high declination means it's, I think it's still technically circumpolar. It's reaching the point where it's almost not circumpolar. But nevertheless, the point is that, yeah, no, it is still circumpolar. But the point is that it stays high in the sky, or relatively high in the sky, for a prolonged period of time, whereas Swan does not. So, it's just basic observability issues there. Alright, I'm going to turn off the porch lights now, and hopefully that will be fine. Now it's nice and dark out here, and yeah, there is like a persistent bit of cloud and haze to the northwest, which is right where that comet's going. That's right where that comet is. So the haze, most of it is staying a little bit below where the comet's position is, but like Venus has a nice halo around it from this bit of haze that it's shining through. Earlier, Venus was noticeably dimmed by it, but it seems to have moved off. So that's why we're able to still get these images of the comet. But the comet is very, very, very faint, as you can see. I mean, it is barely there at all. It's right here. It's this faint little glow in the middle where the mouse cursor is. That's all that's left of Comet Atlas. With a bigger telescope, you could definitely see it better, I would think. Or with a wider field of view, you could probably see it better, maybe. If I did a 2x2 binning, like, I could pull out more of the comet, but I don't want to sacrifice the color data or the resolution for that right now. We'll just see what we get with these images when stacking. Hopefully I get a halfway decent image. I think the last one was pretty good from the 12th. That is the preview image for this video. Was my latest stacked image from the 12th, where you could see the elongated nucleus as it was fragmenting. And that one came out a little better. Maybe turning off the porch lights helped. Also, we have a couple of galaxies here in the view. I want to point them out, but I want to make sure that I point them out accurately. Yes. So this right here that I'm pointing the mouse cursor at is PGC 18467. This is an elliptical galaxy. According to Sky Safari Pro, it is 210 million light years away. And all of this, by the way, is still in the constellation Camelopardalis. We have another galaxy up here, where the mouse cursor is pointing now. This is PGC 18426. It is also 210 million light years away. Did I? Yeah. They both are. Okay. So they're at similar distance from Earth. I was going to say deja vu there, right? This is listed as just a galaxy in Camelopardalis. It's not listed as elliptical specifically. And its visual magnitude is 15.2. So a pretty faint little galaxy there, but it's coming out in these nice 2-minute exposures. I will point the cursor back now at the comet's position so you can see the comet there. Looks like in this picture it's clear enough you can see one of the two major fragments of the nucleus there sticking out a bit at the tip. Right where the cursor's pointed. I think in some cases we get these clear images where the haze isn't so bad. You can see a little more detail. Unfortunately, even adaptive optics can't help you when it comes to clouds and haze. There's absolutely nothing I can do to improve that situation. But I think this will be the best weather I get for a while. And on that note, the other thing I want to make sure I try to get tonight, if I can, is Wolf 359. I will point out elsewhere in the sky, it's not so bad. It's just the northwest persistently has this bank of clouds and haze, and I think that's part of the same system that's currently passing over Tampa. But I'm south of Tampa, far enough south that I've got some decent clearing. Unfortunately, with the scope's position, I'm not sure I could even get Wolf 359 right now because I've kind of got it with some big trees nearby that are blocking the view to the south in favor of getting a good view of the north. But as it gets past the meridian, it should be possible to get it. And the reason I want to get Wolf 359 is later this week, New Horizons is going to take a picture of Wolf 359, and I can compare my picture to their picture. Well, you know what? That might actually be a background star. I thought that was a nuclear fragment of the comet there, but that position happens to coincide with a star, I believe. I'll check that in just a second. But yeah, New Horizons is currently 47 astronomical units away from Earth. So that should actually, 47 astronomical units away from the Sun, not Earth. But nevertheless, that should provide a huge baseline for determining the parallax of Wolf 359, which is one of the closer stars to Earth. So, coming back to the comet for a moment. Yeah, that position is, as far as I can tell, looks to be consistent with a star with a really long name, another one of these Gaia designations from the Gaia database that I put into, purchased for Sky Safari. It was basically a DLC for Sky Safari Pro. Gaia 1008555116781386624. Okay, so that whole long mouthful, I believe, is consistent with the position of that bright dot there. I don't think that's actually part of the comet. I think that's actually a background star that just happens to overlap the position of the comet at the moment. What is interesting, though, is I can see a difference between where Sky Safari Pro is predicting the comet to be right now versus where it's actually appearing in the image, especially if that is that star, because that's right where the tip of the comet is. But Sky Safari Pro, yeah, that star's not moving, but the comet is. But the comet is predicted to be out actually back here. The nucleus of the comet should be back here according to Sky Safari Pro, so that indicates there probably is some non-gravitational acceleration going on there from outgassing jets on the comet, that kind of thing. It'll be interesting to see how well it matches up with my earlier determination of the orbit. So hopefully we can get that with the astrometry from these images here tonight. And I also updated my Comet astrometry program on GitHub. So I have found a bit of a glitch with how it was handling decimals of the right ascension, seconds of right ascension, where you were effectively getting randomized digits past the decimal on seconds of right ascension. Unfortunately, it was reversing the last the three digits after the decimal, and so it was effectively randomizing the numbers instead, which is not ideal. So I fixed that, and that helped me a lot when modifying the program. I encountered that bug when I modified the program to handle asteroids, and then went ahead and did the astrometry on 1998 OR2. I was still getting high residuals, and I expected high residuals out of comet astrometry because the comet is very fuzzy and it's difficult to nail down exactly where the comet is. But with an asteroid, it's a pretty nice tight point of light. Yes, it's streaking in my images a little bit, but I'm going for the center of that streak and going for the midpoint of the exposure. So it should have given me much tighter residuals, and it wasn't. And then I found that bug, and I realized, oh, this is where that's coming from. Once I fixed that, I immediately got much better astrometry on the asteroid. So it'll be interesting. I'm going to rerun the astrometry calculations on the comet from scratch, and rerun the calculations of the orbit. Because the bug resulted in semi-randomized noise to the data, it's a bit like running Monte Carlo solutions. It didn't really matter per se. It did not bias the data in any particular direction, so it didn't have a real impact on my orbit determination other than making it a little less certain, a little more uncertainty in the determination. But the overall trajectory will still be the same. It'll just have tighter residuals and a better determination of the exact elements. But what I'm also curious to see is how the astrometry and the resulting orbit calculation from the pre-fragmentation nights of observation compare to the position of the comet as seen post-fragmentation. What are the residuals if you solve for the orbit while excluding these post-fragmentation nights, and then look at how those post-fragmentation nights match up to the pre-fragmentation orbit? I suspect there's going to be some significant residuals there, but the resulting orbit, if you include the post-fragmentation, or even just focus on post-fragmentation observations, I suspect the orbit will still look the same overall. It's just going to be slightly offset as to where it is in the orbit. Exposure looks a little bit hazier. And I don't think it's tracked as well. I think we're suffering because we're having to run full second exposures on the guide star. The adaptive optics unit is really designed to run faster than this. I'm going to stop this exposure for a second. I'm going to try to get away with slightly faster guiding exposures. Let's see if it lets me. Yikes. I mean, technically yes, We have no room for error here. No. It's a bad idea. Don't do it. Don't do it. Stop. Okay. I tried to fly too close to the sun, and my wings burned off. Okay. It's just not clear enough tonight for that. I'm gonna have to play it safe with full second guiding exposures. There's just too much haze. And not the Fred Haze type. Oh, that was a dumb joke. I just got done watching the Apollo 13 playback in real time on apolloinrealtime.org. And I know I mentioned that site before and tweeted it out as well. Hope some of you guys got to check that out. That was really cool to see the Apollo 13 mission, all the original audio and film footage playing back in real time, 50 years to the moment it happened. Oh, and we lost the guide star. Oh, came back. Maybe. Yeah. I didn't mean to take damage. I meant to run the autodiver again. Yeah, nope. Stop. Okay, stop the image. We are hitting another cloud bank. Yep, it's gonna be one of those nights. Let's center the tilt. Okay. Here's the guide star. I'm gonna move it slightly to the left so it's not bumping up against the edge of the autoguider quite so bad. If we have to go into a situation like this, okay, like that, where you can't even see it, okay, then it popped back out from the cloud. If we end up in this situation where we have to wait a while for a cloud bank to pass, I don't want it to be so close to the edge of the autoguider that it could drift out just by the virtue of the fact that I'm not tracking anything right now. Yeah, you can see it's there one frame and it's gone the next. Yeah, we're just in the clouds at the moment. And that's why I took that last measure there to try to make sure the guide star is not bumping the edge of the autoguider. Hey, Eric Briggs. Give it a few minutes and try again, I guess. Oh, it looks like I just got followed by somebody very interesting there on Twitter. Tony Dunn. Orbit simulations of planets, comets, asteroids, and other interesting stuff. Amateur astronomer, bachelor's in physics and astro. Looks like he's got some cool software he's using there. And showing a rendering of Apophis making a close flyby. Anyway, I was just playing around today myself with an in-body simulation, but nothing so graphically interesting for sure. I don't know if Tony's watching right now, but if you're in the chat, do you run that website, orbitsimulator.com? Or are you just sharing it? I know I've seen that website before. Tony wrote that software. Thank you, Varek. Yeah, I kind of had a feeling. Yeah, we still don't have the autoguide star. Well, might be out of luck on the Comet tonight, beyond the images that we've already taken. I'm seeing more haze coming from the northwest. There's more of the sky that's blocked now by it. That's, unfortunate. Oh, I see Air Briggs in the chat. They were talking about somebody who thinks Venus is Comet Atlas. Was that, were you referring to Against the Grain? I saw some videos where he was insisting that the comet had not fragmented and was showing video of Venus. And the comet is not all that close to Venus in the sky, honestly. Bye, Project, Alice. Yeah, Francis Walsh also had some data on the comet, I guess, or he was, I don't know if he, did he finally get some images of the comet? I know he was showing a pair of what looked like stars that were drifting in the view, but that was before it fragmented and then actually did become what looked like a pair of objects in some of these images I've seen from other scopes, including the Virtual Telescope Project. They've got a nice big 16-inch scope, though. A lot more resolving power than what I've got. There's not going to be much of the nucleus left to align on. Yeah, exactly, which is why with my Comet alignment software that I developed, it's all based on the orbit of the comet. It's aligning it without looking at the image per se, except to look at the astrometry of the image, and then align it based on the astrometry and the predicted position according to the orbit. Yeah, I'm not seeing the guide star at all. Well, what do you think, gang? Do we try to go for something else? And let the comet be? I could go either way on it myself. I did want to get more images of it, but I don't know that the weather's going to let me. I knew it was kind of a long shot tonight. We got something, at least. I feel good not walking away empty-handed from setting up the telescope. But if I sit here and wait for... I mean, I could wait for a clearing. That may or may not pay off. Or I could try to go for something else. Take a look at Orion. Orion is too low. It's setting in the west, and it's now behind a tree for the most part. Yeah, I doubt Atlas is going to do anything but vanish. I agree, Sam. I think the trend on this one's pretty clear. It could always surprise. It could always have another outburst, but I would not bet on it. 1998 OR2. That's a... yeah, there's a good possibility. We can go for the asteroid instead. Let's do it. This just turned into an asteroid stream. Maybe. And hey... oh wow, that's cool. The asteroid is very close to what looks like the Beehive cluster, yes. Not close enough that I could fit them in the same field of view, unfortunately. If I had a wider angle telescope, maybe. But I'm curious. It's not flying in the direction of the Beehive cluster, actually. It's flying by it, but it's not going to intersect with it. It would be cool, though, if you could get the asteroid going through the Beehive. That would be really neat. Okay, so if I want to get the asteroid, I'm going to want a bright guide star. How am I going to want to orient things? Probably going to want to rotate the camera quite a bit. Yeah. Yep, okay. I can see the camera orientation that I want. It's going to require the camera being tilted 90 degrees. Which is fine. I just have to actually do that and recalibrate the guider. But I'm going to have to refocus the telescope near the target anyway. Okay. Alright, what do you think, gang? Last call. We moving on to the asteroid? I think we are. I'm going to take one more picture for good measure. Yeah, the guide star's barely there. It's just marginally there. It's not great. It should be much brighter than that. Venus is low, and this camera is not designed to shoot Venus. This is a deep space camera. I would have to completely switch the optical train to my planetary imager for that. 1998 OR2. Let's go for it. Okay, so I'm going to go reposition the telescope to point at a focus star, to refocus and retrain the autoguider. Okay, first of all, I need to turn off auto-saving. I'm not going to use that for a minute. Need to... oh, did I do that thing again? I did. Wish I could turn that feature off. With Sky Safari, if you point the phone up at the sky, it assumes that you want to turn on the compass, and it just automatically turns it on for you. I don't like that. It's the only gripe I have about that program, otherwise it's fantastic. Okay, so let's take 1 second 2x2. Make sure we're pointed at our intended star. We are dead on. Beautiful. Can't argue with that pointing accuracy tonight. So, let's see here. I'm gonna have to let me think about this. I need to put the camera. Okay, I need to orient the camera like that. Got it. a $10 super chat from Varric Bostrom, 1988 OR2 movie night. Thank you. Appreciate it. Alright, so I got the camera twisted 90 degrees now. And that focusing mask is on. So let's see. Okay. Looks like we're not way off on focus from mirror flop, so that's good. One by one bang. And we'll do 3 seconds. Let's see what the story is. It's not bad, just needs a little tweak. I have no idea if that was a good direction or a bad direction. We'll see. Again. I think that was a bad direction. Okay. Let's see what we get with that one. I don't know. Okay, let's try that. Okay, I think I'm moving in the right direction now, but I also feel like I'm getting clouded out. No! Oh, yeah. Yeah, there's just a little cloud. It'll pass quickly. It's just general haze and nastiness tonight. Okay, let me crank up the exposure, see how close I really am to focused here. I'm gonna call that well enough. That's good right there. Okay. Now it's on to the asteroid. But first, don't forget, gotta recalibrate. I almost forgot. Let's do a 2x2 bending. Auto guide with the imager. Do 0.05 seconds. Is that cloud back for blood, or is that just might just because I'm running such a short exposure? Yeah, okay, that's better. Alright, let's make sure the slack is taken out of the drive. Okay, slack is gone. Calibrate, calibrate, calibrate. There we go. Okay, so now it's going to move the motors around to get its bearings of how I've now oriented the camera. Turned it 90 degrees from its previous orientation so that I can get a nice bright guide star. Successful. Okay, so now I just need to make sure this is symmetrical. That's good. Then I need to calibrate the adaptive optics. As soon as that's done, we will move on to the asteroid. Okay. I'm just going to pull up the coordinates for the asteroid. Okay, beautiful. Let's get it. Now be positioned such that the intended guide star is right in view. Let's see what we get. Okay, it's in view. I'm not even going to bother repositioning because we're wasting precious time. We are just going to go for it. Beautiful. Now that is high-speed guiding. Turn on autosave. You know what, I'm going to put this also, just so I don't forget, it's with the focal reducer. Image, this is going to be 1x1 bin. This is going to be 0.0. Let's do 60 seconds. Go for it. And a $10 super chat from P&K Space Imaging. Thanks for providing for the masses. Smiley face. Thank you. Thank you, P&K. Appreciate it. Always happy to provide. And right now, looks like I'm providing a very nice, sharp image. That's cool. Good looking picture there. Stars are nice and tight. That's what I like to see. So let's get our bearings here. It's a double star, okay. For is the asteroid all the way down here, maybe? No? Where is it? Okay, there's the dark frame taken out. zoom out for this first one to hopefully see something move as soon as the image is downloaded. Oh, come on, move. Huh. Do you guys see it? Why don't I see it? We're in the right place. I'm thinking... Huh. Alright, let's see what happens with the next picture. You guys see? Alright, watch for something to move. I think it's somewhere around this area. I'm probably missing it. I mean, I'm probably just... It's here, and I'm just not seeing it. It's right under my nose, I'm sure. I just have that feeling that it's taunting me. No, not what I wanted either. I'm going to easily just grab it and move it. It's going to be moving up and to the right in the image. What part of the sky? So this is... I know it's near Cancer, but is it in Cancer? What is it? Yeah, it's in Cancer. Oh, you know what? I also see a satellite streak going through here. I wonder if I'm pointed at the geostationary band. That might be a whole series of satellites, actually. Let me turn on show satellites. No, it might have been just one. No, we're below the geostationary band here. But there was one that passed close to this area. It was a Molnia 186. Pretty sure I'm in the right place. And the image... Everything else looks correct. It's just... I don't see the asteroid. I know it's gotta be here. Looks like it should be right around in this area. Magnitude 12.6. It should be easy to see. Unless Sky Safari Pro is just completely bonkers and it's telling me the wrong location or something. Oh wait, it's right here. I just saw it move. Okay. It's been right here probably the whole time. Okay, cool. There it is. Have you guys been yelling at me in the chat? I see it! No motion that I saw. Okay, so it wasn't just me that wasn't seeing it there at first. Yep, it's moving. It's trucking right along. And I saw Varric, you mentioned 4848 Tutankhamun might be in the frame too, 17.4 magnitude. Let me see here. Show asteroids and comets. With names. Huh, that one's not coming up for me on this chart. Yeah. There is one in the autoguider window that's going to fly by the autoguide star in a few hours, but yeah, nothing else is showing for the field of view I've got right now. If I repositioned it a bit, I'd be riding the guide star at the edge of the view, but 2003 YS 179 would technically be in view, but that's magnitude 23.6, no hope of seeing that. I don't even know why he bothered showing me that. And yet it doesn't show me 98 OR2. I don't know, this thing's goofy sometimes. Like, come on, I'm pointing right at 1998 OR2. Why are you not showing me that on the chart? Until I manually search for it and then it appears. Okay. Alright, let me try searching for 4848. Maybe it's just not showing it to me on the chart, but it should be there. I see what you're saying. Well, if Sky Safari Pro is to be believed, it's outside the view to the right. I see it now. I don't know why it shows me like a random selection sometimes of asteroids, and it doesn't really show everything it should. But no, I couldn't even get that one actually if I. Well, like I'd have to move the guide star. The guide star would no longer be in the frame to even get that one. So, yeah, I can't reposition it to fit that one in there. That would be cool though if you could get two of them at the same time. But at least I feel much better. We're getting productive images here instead of trying to battle the clouds and having to shut down the imaging every 2 minutes for a cloud. So that's good. you see nothing. But then again, you've been drinking the last few hours. Well, I can tell you some tales about that. I used to work at when I was in college, I worked at a public observatory, and we had an event we would put on called Cocktails in the Cosmos. Sounded real nice. A great marketing idea, I guess, but in my experience, it was tricky. A tricky event to pull off. Because you're trying to let people look through expensive, delicate telescopes while they are getting smashed. Not a great combo, in my opinion, but then again, I wasn't the one trying to sell the tickets, so I get it. But yeah, the asteroid is right here, right where the mouse cursor is. I'm going to try to keep the mouse cursor close to where the asteroid is. You can also tell it is slightly elongated. It is streaking during the exposure a bit. Even though I'm only running 1 minute exposures, it's moving along at a good clip because it's close to Earth. So the apparent angular rate is much, much higher than your typical asteroid. No more tail. So this is not the Comet. I should probably change the title of this stream. This is turned into the 1998 OR2 Asteroid live stream. We could not get Comet Atlas for very long due to the clouds. We did have it at the beginning, so I'm not, tricking anyone with the advertising of the title, but we had to divert to a secondary target, and the chat actually suggested 1998 OR2, so that's what we've moved on to. Is there even a way for me to change the title while I'm streaming it? I don't think there is, at least not on my phone. So I'll change it afterwards. But as each frame comes in, you can see it. If you look at it, as each frame comes in every minute, you'll see that it changes position. It is moving along up and to the right, as I expected. But keep in mind, this view here is also rotated 90 degrees, roughly, from the equatorial coordinate system. And that was to get this nice bright guide star you see up here. So this bright guide star, I should also give that designation for fun. That is HD 75974. But again, it's interesting that Sky Safari Pro is not showing the asteroid exactly where it actually is. I wonder if... do I have some issue with... oh, I might have some issue with the time zone. For some reason, Sky Safari Pro has goofed up my current time zone for my location. That might have been my problem all along. What is the time right now? 10:20? 10:20, yeah. Yeah, that was the problem. Okay, so that's been my problem all along. That's why the Comet wasn't where Sky Safari Pro was predicting it to be. That's why the asteroid wasn't where I was expecting it to be, because the time zone was wrong. For some reason, Sky Safari Pro thought I was 5 hours from Universal Time instead of the current 4 hours from Universal Time. I don't know how that happened, but I fixed it. Now it's showing the asteroid right where it actually is relative to the stars. It all makes sense now. This is why I had so much trouble finding it initially. It's not my fault, okay? I'm blaming that on the phone. That's the phone's fault. Think I have to go into YouTube Studio to change it? Yeah, I probably do. And I don't know if I'd have to interrupt the stream to change the name, or if you can change it mid-stream. I don't know. I'm going to leave well enough alone on that. I'm not going to experiment with that right now. I'll just change the title afterwards. It's not a big deal. But for anyone showing up, if you see anyone confused and asking, where's the tail? Where's the coma? Why is it just a dot? It's because it's an asteroid. Let them know. Oh, you're getting an Olive Garden salad. I love our Olive Garden salads. Making me hungry. I haven't had dinner yet. I've got some food thawing out right now. I'm gonna I'm gonna go heat it up. So I'm gonna turn up the music and go snack on something. But looks like we're stable on the asteroid for the moment, so looks good. Actually, the northwest did finally clear up for the most part, I say. It's hard to say whether the comet would actually be super clear or not. Honestly, there's not much comet left to see. I mean, you guys saw those first few images, it came out good, and even in those pictures, the comet's barely there. It's really weak. So, I actually don't regret this. I think at this point the asteroid's more interesting to look at. Even though it doesn't have a coma or anything, it's moving along at a good rate, and you can watch it as it approaches Earth here. So this will fit nicely with the video I'll be doing of the asteroid later anyway. It'd be good to get some more images for tonight, because I was planning to do a time-lapse of the asteroid, much as I did the time-lapse of the comet over multiple nights. I was going to take the various nights of observations I've done on this asteroid and throw it into one big time-lapse there as well. So adding some more images to that would not be a bad thing. Oh, very, very good, Varric. Thank you for giving the current distance. That's a great statistic there. Sky Safari Pro, again, I gotta make sure it didn't goof up with the time zone or anything. Why are you doing that to me? It keeps defaulting to -5. It's not. The current time zone is... Well, it is -5, but the... -5, but with the time... Daylight savings time is 4. So we're currently 4. That makes more sense with the position of it. Anyway, it's got it at 9.9 million kilometers currently, and 0.066 AU. Yep, that's the same numbers you gave just now. So it's almost, not quite, but almost twice as far as it will be at closest approach later this month. Yeah, and no worries, it's not going to do anything to us. I've confirmed that myself with my own observations. Hey, we have an asteroid streak right there. It's about to go bye-bye, but yeah, there was an satellite streak through the image right there. Let's see if I can identify that. Show satellites. Of course, every time I tab out of Sky Safari and tab back in, it resets the time zone situation. Come on. Stop doing that. Not sure what that was. Could be a classified satellite. Don't know. But then again, Sky Safari's satellite database doesn't seem to be totally exhaustive. think I'm pretty satisfied that there's not going to be a cloud flying over disrupting my guide star while I go grab some food for the next few minutes. So I'm going to crank up the music here and go grab a bite to eat, but I'll be back. Alright, I'm back. Looks like things are still moving along here. The asteroid's definitely moved way off from where I left the cursor. So the asteroid's now at this position. Let me fire the chat up here again so I can see what's going on. Oh, and it looks like I had missed an earlier super chat from Copernicus Thinker for $2. Cool. Thanks. Thanks, Copernicus Thinker. Has it all but faded away now? Yeah, kind of. The comet's very faded, but we did have some haze and clouds in the northwest. Let me take a look at what that looks like right now. Oh yeah. Takes a while for my eyes to adjust, but there's definitely clouds in the northwest still. That's not a good area of the sky tonight. Doing good for the asteroid though, so that's good news. We did get some images of the comet, but it was not a great comet for sure. Hey Dick Dawson, good to see you. So what is the RA and deck I'm using for 1998 OR2? So I see Bostrom, you had already given a plate solved solution, right? Or I'm not sure if the coordinates you gave were from plate solving, just the center of the view here, or if that was for the asteroid itself. Let's see. Again, I have to fix... I don't know why it keeps getting my time zone wrong on Sky Safari. That's silly. But if I fix that, current coordinates according to Sky Safari are 8:53 16.76, 19:51 32.6 deck. All right, so that was epoch of date, not J2000, because that's what my telescope is expecting for the hand controller. So again, at epoch of date 2020, we have right ascension of 8 hours 53 minutes 16.76 seconds, declination 19 degrees 51 minutes 32.6 seconds. And I'm guessing that Varric, your coordinates probably would have been J2000 anyway, so there's going to be some difference there. The second and third coordinates are plate solved. Cool. Cool. For the asteroid, great. Yeah. Those would probably have been at J2000, of course. Yeah. Yeah, exactly. But the LX200 will be expecting epoch of date for its coordinates when putting into the hand controller, so that's what I just leave my Sky Safari Pro set to. What's the difference between a comet and an asteroid? It's a good question. So a comet exhibits cometary activity in the form of gas and dust. You have a coma surrounding the physical nucleus, and you oftentimes will have a tail forming as well due to solar wind and radiation pressure pushing the dust back away from the sun. So comets are icy bodies, whereas asteroids tend to be drier. They don't tend to have as much volatile material, or in some cases you can have an asteroid-like body that's orbiting deep in the solar system, far from the sun, where it doesn't ever get heated up enough to exhibit cometary activity anyway. Sometimes they'll find a trans-Neptunian object, maybe even in a somewhat elliptical orbit, but never gets close enough to the sun to heat up. You know, it's possible some of those might have volatile ices on them too. But comets, especially long-period comets like Comet Atlas, come from even deeper in the solar system, from the Oort cloud, very far from the sun. So even beyond the Kuiper belt. And these icy bodies heat up as they approach the sun, and the ices start sublimating directly from solid ice into gas and carry away dust and material off the surface when that happens. And that forms the coma and gas cloud that surround the comet and can be much, much larger than the comet itself. Because both in terms of an asteroid or a comet, the physical nucleus tends to be pretty small compared to a moon or a planet. We're talking something just a few kilometers in size. So it doesn't have a whole lot of gravity on its own. And so it doesn't have the gravitational force needed to hold that gas and dust to itself. It's not gravitationally bound. So that coma just keeps expanding out into space, away from the physical nucleus it came from. And so the coma can be quite large, but the physical body is much smaller. It's more like the size of an asteroid. There are even asteroids, a few, that are thought to have once been comets, potentially, but are now dormant bodies. I think, I'm going to mess up the name if I go off memory, but it's like Phaeton or something. What was the name of that asteroid? Phaeton? 3200. So yeah, asteroid 3200, Phaeton is in a highly elliptical orbit. Looks more like a comet in terms of the orbit than an asteroid, but it's considered an asteroid because it's currently dormant. It doesn't exhibit it doesn't exhibit comet-like activity. Nevertheless, it does seem to be potentially the progenitor of a meteor shower. And the Geminid meteor shower, I believe, is what it generated. Is that right? Geminids, yeah. And yet, the asteroid's not exhibiting comet-like activity. But maybe at one time it was an active comet, and it left behind material that forms the Geminid meteor shower. Now, meteor showers, the material that comes off a comet can form a meteor shower, but that tends to happen when the orbit of the object intersects the orbit of Earth. So the minimum orbit intersect distance will generally be pretty low for bodies that cause us to have meteor showers. So in the case of 3200, asteroid 3200 Phaeton, we're looking at a Earth minimum orbit intersect distance of only 0.019 astronomical units. Now you look at Comet Atlas, for example, the minimum orbit intersect distance is over half the distance to the Sun. It's more than 0.5 astronomical units. It's more than 0.6, actually. So there's no chance that it gives us a meteor shower because its orbit does not come close to intersecting our orbit, and that material that forms the meteor shower tends to be stuff that's left behind in the orbit. So that's the lengthy explanation there. But it's still unknown, I guess, whether 3200 really ever was a comet. It could be that it had a collision with another object, and maybe that scattered material. But if you look at the orbit, it's very elliptical compared to your typical asteroid, although some near-Earth asteroids can be in fairly elliptical orbits. And it does get quite close to the Sun. And yeah, okay, that's cool. So earthsky.org has this article about it, and they actually do show an image, a close-up image of it, when it's very close to the Sun. An image from Stereo Head showed it in 2017 having a small tail to it. But because it does get so close to the Sun, you know, it heats up quite a lot. So even if the stuff on the surface wouldn't normally be volatile, it might be made volatile by those extreme temperatures. So there you go. There's the article to that particular interesting mystery body. So this asteroid that we're watching tonight, 1998 OR2, doesn't seem to be exhibiting any comet-like activity, but it is interesting to watch. It's currently getting closer to Earth, and it's going to get down to about 16 times the distance to the Moon at closest approach later this month. And I'll be doing a video on my analysis of the coordinates and the resulting orbital elements. So check back on this channel for that later on. Oh, Guide Star lost brightness. Woo, hi. We've got a cloud going over. Oof, oof. Well, that was not good. The armrest on my chair gave way too, and I leaned back. Yeah, okay, so we're gonna stop taking pictures now here for a second. Let's see. Yeah, I can't even see the guide star at all at this point. Well, I'm gonna fire up my phone here to take a picture of the scope as the clouds go over and get an idea of what it looks like. Yeah, we've pretty much got complete cloud cover suddenly. There's some gaps in the clouds, but it's not great. I think it's coming out of the west. Yeah, that's where all that stuff's coming in off the Gulf. So I was shooting 1998 OR2. It was an asteroid last seen right here in the image, I believe. But at this point, we're not shooting anything. So Bara asks, how is it possible that an object half the size of the Sun can't be seen when its distance from Earth is the same distance between us and the Sun? Well, the coma, the maximum extent of the coma, at one point was said to equal about half the size of the Sun, but that is a faint cloud of gas that it came off the comet. It's not a solid object, and it's very tenuous, especially at its outermost extent. Even with my telescope, you wouldn't have seen all of that. You could see some of the green glow around it in one of the pictures, one of the stacked images I took in that last time lapse that I uploaded. One of the frames, right before it began disintegrating, you could see this green glow around it. That's the coma. That's the faint gas that they said was up to half the size of the Sun, but it's very, very tenuous gas, just a few particles per cubic centimeter at most, maybe even less than that. And so it's very easy to not see it because it's very thin. You could see stars right through it, and you need a pretty sensitive instrument to even pick it up. The physical nucleus is extremely tiny. We're talking just a few kilometers. It's getting to be that time of year, clouds and such. Yeah, exactly. We're getting into that summer weather pattern here in Florida. Not going to be so good for astronomy at that point. Glad I was able to get a little more time out here tonight with a scope. Got some initial images of Comet Atlas, what's left of it, and then moved on here to 1998 OR2. But that might just do it for tonight. I was really hoping to get some time on Wolf 359. And I don't think these clouds are going to play nice. Let me see what the GOES weather satellite looks like at this point. Yeah, it's spreading down south towards me, isn't it? Yeah. There's a thin line right where I'm at the moment. Right over my town. But it's pretty bad news up towards Tampa, looks like. And all through Orlando, all the way out to the East Coast. So we're in pretty tough shape, unfortunately, on weather at this stage. What's the oddest thing I've ever seen in the night sky? I have to think about that one. The oddest thing. I did see a spike of light one time as I was doing the webcast that I never confirmed what it was exactly. It could have been a satellite that was flaring like an iridium flare, or I thought more likely it was probably a meteor streak through an image. It was years and years ago. I guess that's about it for odd things. It was not anything that I thought, oh my goodness, this is, little green men or anything, but just unexpected. Not a terribly satisfying answer, I guess. Good evening, Scott Mayer. Starlink was pretty cool, not odd. Yeah, see, that's the thing, like, I can think of things that I've seen that most people, if they didn't know what it was they were looking at, they would think it was very odd. Like UR's satellite, right before it burned up on re-entry, I saw it probably within one orbit or so of it burning up in the Earth's atmosphere. And at that point, it was spinning very, very rapidly. And due to its rapid rotation, it was blinking. Because when the shiny part of the satellite was reflecting the sun, you could see it real bright. And then it was immediately rotated to such an extent that it was not reflecting much sunlight, so it would appear to blink on and off in a really, really sharp light curve, just on, off, as it's moving rapidly through the sky. And it produced this really unique visual effect. And I was expecting something like that. And I went out to look for it. I remember I was tracking it, just looking at the orbit on my computer on my desktop in my room, and I ran out and looked at it as it passed overhead, and sure enough, there it was. And if I hadn't known what that was, I would have thought that was real odd. But I knew exactly what it was. It was a satellite that was rapidly rotating, tumbling out of control right before burning up in the Earth's atmosphere. Red's face and UFOs are allowed. Yeah, I mean, I really haven't seen anything at night that I didn't know what it was necessarily. Like Starlink, I mean, I've seen a train of Starlink satellites going over my house not that long ago, in fact. And again, if I didn't know what it was, yeah, I'd probably think it was odd. But I knew what it was. I was looking for it and expecting it. I did see the X-37, the secret space shuttle, exhibit a flare, like a satellite flare, the first time I tracked it. As a matter of fact, it was the very first time they had launched the X-37B, and I wasn't expecting that. I was expecting to see the shuttle, this secret space shuttle, but didn't expect the flare that I recorded, and reported that, and it got featured on spaceweather.com years ago. So, again, that's not super mysterious or anything, but it was unexpected. Okay, I am seeing a clearing approaching. Now, at this point, I'm going to take it off of the Asteroid. Sorry, gang. We got 70 images there, it looks like, of Asteroid 1998 OR2, which is good. Those will go into a time-lapse later. But we're going to go for Wolf 359. I'm going to try to reposition the scope here. Let me see if I've got a good angle on that. I got a pretty good photo with the scope staring up towards the clouds. I'll share that with you in a minute. let's see here. I think for Wolf 359. There's that stupid time zone thing again. It's so weird. So, yeah, I'm doing good, Renee. We're clouded out at the moment, but there is a clearing coming, and I'm going to try to shoot Wolf 359 in preparation for parallax measurement in combination with images from New Horizons later this week. So I need to reorient the camera again. That's unfortunate. Unfortunate, but necessary. Okay. I'm going to go ahead and get the scope going on that. It's a little tricky to try to loosen the camera against the focal reducer and get it rotated. But I did it. Now, question is, can I see the star that I'm trying to point at? Answer is no. Probably due to clouds. I think that's probably a hit right there. I'm guessing. Yep, that's it right there. I do have a clearing coming, even as I speak. Okay, good. Now let's get focused up on that star as quickly as possible. So, diffraction spikes aren't really easy enough to see in that picture. Gonna need some more exposure on that, unfortunately. Okay, good. That's much better. That actually looks pretty good. I'm gonna call that well enough, actually. We're not going to do anything. I'm not going to touch the focus. We're going to leave it there. Okay. Now we have... Oh shoot, I should have... Too late now. I was going to... I got to recalibrate the autoguider again. Okay. Let's do a second exposure. Take a second. Okay, there's our guide star. Take out the slack. I have to retrain the autoguider. Okay. Okay, this is tricky. Let's do 0.7. I need to make sure it doesn't show, and ideally, none of the other stars should be showing up in these pictures. This is not ideal. This is not the ideal thing. Okay, I don't know if this is going to work or not. We're going to try. And I also don't know how long we'll have a clearing. It's kind of patchy clear. It's not perfect clear. It's patchy at the moment. Okay. That was almost off the image there, but not quite. Drive calibration successful, so it says. Okay, I know that's wrong. It locked onto the wrong star on that. That's funny. Okay. 271, where we're at. Okay. Let's take it back up, back up, back up, back up, back up. Let's calibrate the AO. Okay, it says AO calibration successful. Let's check it. That looks reasonable. Okay, center. EL. Start auto-guiding. Oh wait, no, we can go faster. We can go faster. That's good. Okay. Autosave on, Wolf 359. Make sure I took off the focus mask. Pretty sure I did. Okay, we're in the clear for the moment. Oh, guide star lost brightness. No. I said the terrible word I shouldn't say. Clear for the moment, which means about to not be clear. That patchy stuff. There's definitely a nice clear spot of sky coming this direction from the northwest, I think, or from the west, maybe. Maybe not. I don't know. I might be misreading the direction of the clouds here. It's hard to see it. They're just faint. Very hard to see by eye. Okay, there's our guide star. Let's try it again. And that guide star went out fast. That's a problem with this. Okay. I'm going to try 2-minute exposures. Sure, let's try 2-minute exposures. Okay. I have to watch that guide star like a hawk. And the moment it goes out, shut off the auto-guiding so it doesn't chase its tail. Yeah, I jinxed myself, that's for sure. And yes, I was using a Batinov focusing mask to verify my star was in focus there. So now we're going to take a shot of Wolf 359 to get parallax on it after New Horizons takes a picture of it. Oh, no. I spoke too soon. Stupid clouds. Come on, give me a clear shot. Oh, no. It's barely there. Okay, well, I can give myself a little buffer room by taking longer auto-guiding exposures. So if I don't get... Oh, well, completely clouded out. That's what that looks like. I spoke too soon. Center. Just take a 10-second auto guide. Just see if I can even see it at all through the clouds. Yeah, I can see it. Just have to be patient. Which I'm not feeling terribly patient right now. There it is again. It's just these little puffy clouds that just come in and muck things up. Right when you go to actually try to guide. Oh, nope, see? It fades in, it fades out. I mean, I'll give it point 2. Ugh. Yeah, just gonna have to be patient with it. Hey, Lamoon, good to see you. We've been tracking a comet, tracking an asteroid, and now we're trying to take a picture of a stationary star. Wolf 359. Star Trek nerds like myself know Wolf 359 as the site of the Great Borg Battle from Star Trek The Next Generation. Locutus of Borg versus the starships of the Federation. But right now, Wolf 359 is behind clouds. So I'm waiting for it to pop back out to take the picture. And they actually used the name of a real star for that episode, a star that actually is relatively close to Earth. It's only 7.78 light years away. Okay, yeah, fair point. Touche, Bostrom. It's a high proper motion star. I meant relative to the asteroid or the comet, which move, so fast that you can see it in a single minute exposure. But I see what you're saying. Yes, it is a high proper motion star. As are most stars that are close to our solar system. And that is one reason why I want to try to take this picture as close in time to the New Horizons picture as possible so that proper motion is not a factor. So, let me go ahead and post a link to while we wait. I'm going to post a link here to the article that JPL released about the New Horizons Parallax program. So you guys can check that out, because that's what we're doing now. So, New Horizons is scheduled to take these pictures at 4 hours Universal Time and 10 hours Universal Time on April 23rd of Wolf 359. So that's coming up this coming week on Thursday. And actually 4 hours Universal Time, that is right about now. That's midnight Eastern Time. So we are 5 days away from that. Well, okay, no, sorry, 4 days away from that, because it'll be the 19th here in a couple minutes. And then, well, okay, but then it's 19th. Yeah, that's correct. 4 days. I can still do math at midnight, not a problem. Hey, we got our star back just in time too. Okay, let's auto guide. All right. We will try this again. Take picture. So in 4 days, New Horizons will take a shot of the same star from its position 47 astronomical units from the Sun, which will form a nice baseline with my telescope to be able to see the parallax. Yeah, sometimes a shooting star can appear to be shooting straight up versus grazing across the horizon in parallel fashion. Yeah, you can see that. If you look at long exposure shots facing oh jeez, good lord, there's some giant moth buzzing around my laptop screen again. He hit the keyboard so hard he almost pressed a key. I'm a little worried he's going to hit the abort button. What was I saying? Oh yeah, if you look at the point where the meteors appear to be coming from, what do you call that? Why is the term blanking in my head? What's the term for the point that the meteors appear to be coming from in a meteor shower? Oh boy. Radiant. Is that right? The radiant point? That's the term I was looking for, I'm pretty sure. If you take a picture of that point in a meteor shower, sometimes you'll see some of those meteors appear to be moving up. There's one picture I was thinking of that I saw a few years ago that was really beautiful, where you could really see that. Oh yeah, there's one in the Perseids. But here's one from Reddit, for example. And you can see, yeah, some of them look like they're streaking down towards the horizon, but there's also meteors coming from the radiant that are going up in the image as well. So here you go. Check that out. Yes, thank you. Radiant. That's the term I was looking for. Alright, so here we go with the dark frame. And Wolf 359 hopefully will not be behind the clouds when the dark frame is done. Let's see. Oh, guide star is still there. That's good. That's what we want to see. Okay, so... Oh, I spoke too soon. I jinxed it. I jinxed it. I jinxed it. Oh, there it is. Okay, it's there. I just did a reset on it, and for some reason it popped back out. Okay. So I'm pretty sure. Yeah. Yeah. I'm cross-referencing all the stars, and it definitely looks like this one right here that the mouse cursor was pointing at is Wolf 359. This is the longest ground-based parallax I've ever known an amateur astronomer to do. Thank you, Kaiser Cube. Yeah, I think this is going to be a new record for amateur astronomers everywhere who participate in this little experiment. Oh, you can see that guide star getting real fuzzy there. Little bit of cloud cover came over. Not enough to completely blind it, but it was getting close. Alright, let's see how this picture looks. This picture could have been completely ruined. Most likely. It's a little hazy. You can see how it got brighter and the stars all got dimmer. Yeah, that was that cloud cover. Still there, though. Still there, so we'll take it. We'll take what we can get. Too bad we couldn't have Voyager 1 and Pioneer 10 do a parallax measurement. Yeah, that would be really awesome, huh? Here for the moment. Man, I should stop saying that. I'm just jinxing myself every time I say it. Right there, where the mouse cursor is, that's the star. We're going to be measuring its distance with the assistance of the New Horizons probe and this image. So where you're supposed to be looking, it's a straight line of stars. Yeah, there's this straight line of stars that comes to a point here. This is Wolf 359, as far as I can tell from my sky chart. Kind of have to hold it upside down, though, because the camera is upside down. Oh, that's a much better picture. I'll probably reject that last one from the stack. But yeah, this one's a much better shot. So, cool. What's the field of view on New Horizons? I'm not sure what the field of view is on that camera. I'm going to have to look into that. I'm sure they mention it and give all the details in that link I posted earlier. So, let's see. Wow. Okay. I'm looking at, so keep in mind this image is inverted as well. Yeah. That's a good one. That's sharp. Trying to see where they might mention the field of view of the New Horizons camera that's going to be taking this picture. Sure. Alright, well, we'll find out. I don't see where they mention specifically. They show a finder field with an axis that goes from about positive 450, maybe 475 arc seconds to negative 475, and about the same with the cross. So, you know, maybe looking at a field of view here that's less than 10 arc minutes. Or what am I saying? Well, that's... No, it's 900. No, sorry. 15 arc minutes. 15 arc minutes. Because the total length, then, if you take it from positive 450 to negative 450, that's 900 arc seconds. So that's 15 arc minutes. 15 arc minutes wide, 15 arc minutes tall. It's, let me post this link. I don't know if that's actually representing the field of view of the New Horizons camera, but the chart they show to help amateur astronomers find it covers an area of the sky from about here down to here, maybe further down a little bit. Across this, so this triangle of stars here is in the image, and keep in mind the image is inverted here, so if you flip this left to right, you would get the finder chart that they're looking at there for Wolf 359, the one on the left at the link I sent you. Put it there in the chat. And so the field of view is like this. It's like an imaginary box around Wolf 359 right here. You can see the bright star here, that star there on the finder chart, and it goes from about there to there to there to there, like that. Okay, so that's the box they're showing, and I'm guessing that's going to be similar to the field of view of New Horizons, but I don't know. It could be more, could be less. Depends on what kind of camera they're, or what the optical system is that they're using. Let's see. And I don't know off the top of my head what the field of view of their scopes were, or their optics on New Horizons. So let's look at the Long Range Reconnaissance Imager, LORI. The instrument had this 1024 by 1024 resolution, 12 bits per pixel monochromatic CCD at a resolution of about 5 microrad, or about 1 arc second. So yeah, that sounds about right. If it's about 1 arc second per pixel, that's a little more than 15 arc minutes by 15 arc minutes. I bet you that's what they're doing. I bet they're using LORI. That adds up, at least, with that finder chart that I linked to. That's cool if that's what that is, then. And I wonder how long it's going to take them to downlink that data. The data rate to New Horizons is, you know, pretty low, because that thing's way out there. The signal-to-noise ratio is not that high. So it's probably going to take them a while to download the image, I would imagine. I don't know. Depends, I guess, on what they do. Are they stacking on board the spacecraft and then downlinking one master file? Are they taking multiple exposures and downlinking all of them and then stacking them? Or they're just taking a single shot exposure and saying, here you go? Could be that. Could be that. Alright. Sorry, that whole question got me off on a lengthy tangent there, looking at that stuff up. see somebody in the chat's concerned about the lockdown actually being about asteroids hitting. Well, I don't think so. I mean, I've independently tracked this asteroid tonight that is going to be flying by Earth, and yeah, it's a big rock, but it's going to stay a safe distance away, 16 times the distance to the moon. I've done my own calculations of its orbit based on tracking it over the last few weeks, and that's what the data shows. It agrees with the official orbit, so there's no cover up there. It's going to pass us by safely. And you know, no one can stop you from taking pictures of asteroids out in the sky. You can rent time on an eye telescope and get images like these without even having to own the telescope. So yeah, no need for concern, no need for alarm there. Looks like we got a decent clearing here, thank goodness. So we can hopefully get some nice pictures here of Wolf 359. After this exposure, I'm gonna chance it. I think. Yeah, why not? I'm gonna chance it. I'm gonna crank up the autoguider speed, double it, and improve the guiding rate. The faster the guiding rate, the sharper the image, in theory. So we're going to go to 0.1 second, because this guide star is nice and bright when it's not clouded out. There we go, much better. And we'll start the exposures again. So now we're guiding at 7 Hertz instead of about 4 Hertz. As long as we don't get a cloud, knock on wood, we'll be good. Gather my Ferengi gambling skills and get that image. Yeah. Oh, I would not make a good Ferengi. In the meantime, though, let me pull up that image that I saved from the phone. I took a shot of the telescope while we were having the cloud issue. Let's see, I think it's this one. Yep. That's the one. Okay. So this is when we were on the asteroid still. And the clouds came and ruined it all. How do I rotate this thing? Oh, there we go. Rotate. There we go. Shrink that down. Not so large, please. This is with my Google Pixel 4. Does a great job. I tell you what, this has become my go-to camera for taking wide-angle astrophotography photos like this, or nighttime photos. I hesitate to call this astrophotography, with cloud photography at this point, but it's become my go-to camera for that, even over my SLR, just for simple, easy stuff like this, where I just want to see it. I don't want to fiddle with manually stacking images myself from the SLR. I just want a quick shot. Boom, done. Does a decent job for that. Yeah. I don't like anywhere I put this thing. It's kind of in the way. Here. So there you go. You can see that. And there again is Wolf 359 right there, where the mouse cursor is pointing. So you can see the cloud issue we were dealing with there. That was pretty significant there for a while, but it moved off finally, sort of. Again, I'm speaking way too soon. There are still traces of clouds in the west that I see. But we are getting images here, so that's good. Yeah, the weather is not being my friend tonight. It's much better now. It cleared up pretty much. In fact, I'll take another shot here because I think there's still some traces of clouds, but now you can actually see stars. Oh, how much time before the star sets? Quite a long time. It's currently almost 70 degrees over the horizon. It doesn't set until 4:55 a.m. They deliberately picked a good time of year to take a picture of Wolf 359 so everyone would have a chance, especially since they're going to take it at midnight as well, which is perfect for us here in America. So right about this time of night is when they're going to take it from the spacecraft about 4 days from now. Yeah, you can see in the photo it's taken with the cell phone right now. There's traces of clouds to the south. But they're staying clear of constellation Leo, which is where Wolf 359 is located. Fun little Star Trek trivia for you guys. If you ever watch the movie First Contact, where the Borg again attack Earth, at one point Zephyrin Cochrane mentions the constellation Leo. Forget his assistant's name, but she's pointing at the Borg sphere flying overhead. She says, "What's that?" He says, "That's the constellation Leo." And I think that's probably a little nerd reference to Wolf 359, which is where during the series they battled the Borg as well, and that star is in Leo. And funny enough, they were, I guess you could say, they were accurate when picking the date of when they travel back to. When he says that, I believe it's April. April 5th, 2063, yeah. So, yeah, that is a month in which you could see Leo at night. So yeah, some little references there for Star Trek nerds like me. Oh, you noticed it got sharper there, Kaiser Cube, when I upped the guiding rate? I hope so. I bet it did. Because now it's guiding at insane speed, 7 hertz. I mean, that's crazy for most people. The beauty of the adaptive optics system. Those stars are nice little pinpoints. That's what we want to see. That'll make it easy to get really good measurements, really high quality, high resolution astrometry, and really good measurements on Wolf 359 for measuring its parallax. So ideally, I will try to shoot it on Thursday night at midnight. So that, well, I say Thursday night, but actually, they say, they said it might be Wednesday night, because it's April 23rd. Oh no, wait. No, April 23rd at 4 hours Universal Time. Yeah, that is early Thursday morning. Right. Okay, so it's actually Wednesday night, effectively. Early Thursday morning is when that's going to be. So, come Wednesday night, early Thursday morning, at midnight, I would like to be shooting it again at exactly the same time the spacecraft is taking its shot. Effectively, it won't matter. I mean, they even say on the website, if you're within a week of them taking the shot, it's valid. You won't get noticeable proper motion in a week. But, I mean, ideally, if the weather cooperates, I would love to take a shot at literally the exact same time as the spacecraft. That would be epic. But I can't guarantee that the weather's going to let that happen. So, take it while you got it, is what I say. Get your shot in when you can. So this is my new contingency shot. I took one early in the month, a rather poor shot, to be honest, of Wolf 359, where I just quickly got a quick shot before it set over the trees after streaming Atlas one night. But tonight, I think, is a better night to get some more time on this, since Atlas has diminished quite a bit. And the weather is not really cooperating at this point for getting a smooth time-lapse on 1998 OR2 at this point. So it's like perfect conditions to try to get this shot, because it doesn't really matter if it gets interrupted here or there with clouds intermittently. We're not trying to really time-lapse anything. We're just trying to get still frames to stack together to make a high-quality stacked image of the star. Let's see if the Pixel 4 took its shot of the scope now. That's a real pretty shot of the scope there. The blue light from the stream capture card backlit the well, not backlit, but it had a nice highlight on the telescope. What's that light there? Oh, that's the power panel on the telescope. Okay, cool. That's a cool shot. Let me put that on the stream. Okay, let's see. So I'm just gonna see if I can swap out that picture for the other picture. There we go. So now you can see there's still some clouds out there, but it's not as bad as it was. Thank you, Jonathan. It's an LX200 Classic 8-inch with an Orion piggybacked, which is doing nothing for me. It's actually just acting as a paperweight to make sure the scope's properly balanced. And the camera is an SBIG ST2000 XCM with an SBIG A07 adaptive optics unit. Some light haze. There's some light haze coming up towards Leo. But it's not super thick. I think the thick stuff's kind of gone, but there's just some general haze. I mean, it's a decent rig, but it's not the best that's out there. I mean, I go to some of these big national star parties like Chiefland, and I frequently have the cheapest rig out there that's doing any imaging. Some of these guys have really nice, you know, Takahashi scopes on Losmandy mounts that are super expensive. And I'm poking along with a little Meade LX200 Classic. It's a design that's over 20 years old. I mean, the scope itself is literally 16 years old at least. I bought it, and it was old stock that was left over. It had been collecting dust for who knows how long. And I've had it myself for 16 years now. So, it's not top of the line by any stretch of the imagination, but it does the job. It gets the job done. I'm not knocking it. It's very special to me. I have a lot of, at this point, I have a lot of memories built up with this scope. Taking it to various rocket launches, seeing the very first Falcon Heavy, you know, seeing the total solar eclipse in 2017 in Wyoming with this scope. I mean, it's got tons of memories built up into it. I'm just never going to get rid of this scope. It's very special. It's not the best, but, you know, like the Millennium Falcon, it's beat up, but it's got it where it counts. I've finally got, the equipment set up with the right combination to get some decent shots, where you can see here how the stars are all nice and tight and round. It does have a bit of coma with the optics, but, it's not terrible. The shots it takes are decent. And when you consider the price, it's significantly cheaper than the next step up in amateur astronomy, which would be usually, if you wanted to upgrade every element of this thing to be the next step up for deep space astrophotography, you're talking an order of magnitude difference in cost, at least. And the thing about this scope is it's versatile. I can do deep space astrophotography like this on a night like tonight, and then the next day I can take it down and reconfigure it to be altitude azimuth aligned for maximum stability for a rocket launch. So it does it all. It's my Swiss Army knife of telescopes. Oh, that one came out even better. Alright, sorry I just bumped the mic. But I got another shot here of the scope doing its thing. That's it's actually a pretty nice picture. Let me share that on the stream. Also, the Arecibo Twitter account posted a radar image of 1998 OR2 today. Very cool. Thanks, Bostrom. I'll check that out in a minute. Okay, so here's the latest shot of the scope as it's taking these images right now. This is with a Google Pixel 4 XL using the astrophotography mode. So there you go. Yeah, it's pretty decent. So I will be right back in just a minute, and then we'll take a look at that shot from Arecibo. Alright, so the integration I was running on my desktop of the orbit of 1998 OR2 is finally done, and it shows it will miss Earth quite cleanly. Alright, at this point, Wolf 359 is getting into the haze, I think. These images look brighter than they did before. Pretty sure we're in the haze at this point. That's not so ideal, is it? So, go ahead and stop this image, and I'm going to do one more check on the focus here. It's hazy all over the sky at this point. Just looking up at some of the stars, they're dimmed and they're fuzzy from all the haze. Pointed at a nearby bright star, threw the focus mask on for the heck of it, and curious what we get. This is more of a after the fact, just checking to see if maybe I need to just restrict myself to the starting images, or if wanted to see what kind of mirror flop I got over the last however many minutes. Not really what I wanted. Okay, fine. I just wanted to zoom in, but you do what you want to do there, program. Hey, that'd be great if I could try not hiding it. I mean, it's a little, could use a little tweak, but I wouldn't say it's way off. Yeah, it's decent. It's not perfect, but it's decent. See the central spike running through that's a little bit below the middle, maybe. At least on this side, I'd say even maybe on this side. It's just, could just use a hair of a tweak, but I'm not going to sweat it. I don't think the focus was way off or anything. So yeah, that's, I think, gonna do it for tonight, to be honest. We are in hazy, very hazy conditions at this point. We can try maybe one more thing for fun. I don't know. No, I think we're pretty much done for the night on whether I should probably use what time I've got to take some flat fields and calibration frames to get the best possible image of Wolf 359, because I just don't know what the weather's going to do later this week. So Wednesday night / early Thursday morning is when I'm going to try to take another picture of Wolf 359 simultaneously with the New Horizons probe, but that is going to be up to the weather to decide whether that even happens or not, and I'm not counting on it. So fortunately we were able to get some decent shots of it tonight. Let's see what the weather forecast says. It says partly cloudy on Wednesday. I mean, we'll see. Maybe we'll get lucky. I'm gonna give it a shot, but definitely wasn't going to put all my eggs in that basket. So thankfully we've got at least a contingency photo from tonight. Really, a few days of proper motion on that star is not gonna matter. It's not really gonna show up, especially compared to over 40 astronomical units of parallax for the baseline. So that will be nice. One way or the other, that will be nice. So let me check the chat here, see if I missed anything while I was gone. I see Kaiser Cube, you posted your rig, that's cool. Looks like a Thousand Oaks solar filter on the front there, that's cool. So, anyway, yeah. Yeah, I think we'll call that one a success. We had to dodge some clouds, we had to struggle a bit, but, man, sorry. Had to struggle a bit, but, in the end, we were successful. So we got images of Comet Atlas, we got images of 1998 OR2, the asteroid approaching Earth, and we've got images of Wolf 359 for a parallax measurement. So that's great. Stay tuned later. I'm going to be uploading a video analyzing the orbit of 1998 OR2 from the images I've taken. Until then, clear skies, folks. Have a good night.